so today is just a quick tutorial video on the task that we, the students, the lecturer has given us to do. And so this is just a quick one that it should demonstrate how we, me myself, understand and on the things that I understand on automata theory as a course. And so as Mr. Wonder taught us some concepts in automata theory, and today I have the chance to just talk about some things that he taught us, and so he gave us some work for us to do, and that is what I am here to do today, to present my findings, the research and then the things I know concerning what you have done so far this semester. By the way, my name is Jim Stanley Blanks, and my next number is 2425402029. And without wasting my time, let's just quickly jump into the technical know-how of how machine computes, machine computational, this kind of stuff are also concerned in computer science and as well as cybersecurity. And so let me just quickly just get the question for you so that we understand what you're trying to do here. And so our task one here today is to provide the set builder notation for the following questions, following terms. And so the sets of strings over the alphabet 0 to 2, 0, 1, 2, that begins with 12. So basically saying that maybe the machine will accept any alphabet that begins with 12, 1, 2. And so let's just quickly jump into the like I said, the know-how of what we are doing here. And so here for part A, I had to write set builder notation for 4 languages separately. For I, strings over the alphabet 0 to 2, that begins with 12. I wrote L equals to the set of strings, set of strings like 12x, where x is any string over the alphabet, like I said, 0 to 2 or 1 to 1, 0, 1, 2, including the empty string. The idea here is the string must start with exactly 12 must start with exactly 1, 2 numbers, 12 numbers, like 12. The initial values for this string has to be 1, 2, followed by another the numbers, right? And so include, like I said, and after that anything goes. So after you get the 12, anything that comes after the 12 will go. Like maybe the machine will accept the language of a particular maybe another machine, right? And so the string, let's just put it that way. For I strings over the alphabet, one alphabet A to Z, that contains at least AB. And so I wrote equal to x AB y, where x and y are the strings over the alphabet. So some plenty of numbers before the exact pair AB, maybe in the middle or somewhere else, and stuff like that. So basically we are just trying to say that L is such that L is equal to 12x, and x is a member of that particular alphabet, 0 to 2. That's what you're saying. And so in the I, that's what you're trying to say. The x a b y is such that ay is a member of the alphabet, and so they are also included, right? And the string, the next part is I, string over the alphabet d. I don't need to say there, but it's th. So THA with only one copy of the. This one is a trigger because it's not just contains it contains the exact ones. Like, so I wrote L equals to x, where x and y are strings over in the curly brackets or something in the right, as you can see, T, H, E. But with the extra condition that neither x nor y maybe satisfy them, and so that condition is what forces the exact how do you call it, one occurrence in, and not 2 or more. So such that x the y such that xy is a member of THE, and exactly like what I said. So that is the same thing that I did to the IV as well, such that strings over the strings that represent positive odd integers. And so for positive odd integers, I treated it as a string over the digits 0 to 9. Two conditions, no leading 0, because otherwise it wouldn't be a normal way to write a positive integer. The last digit that has to be one of maybe 1, 3, 5, 5, 7, 9, because that's what makes a number odd, right? Yes. And so I've just talked about the part A as a set builder notation, and let's just quickly jump into the DFA construction over the alphabet XY. So for DFA construction over the alphabet XY, this is part B, so I need to get the question also, and then so that you also know what you're doing here. So part B, construct the DFAs for the following languages over the alphabet. What is that? I think it's XY. Yeah, it's XY over the alphabet. It's curly brackets X comma Y. Oh yes, I'm sure, probably. Yeah, so that's what I read. So set of string that ends in XY, set of string that ends in XX, set of string that ends in YY. Right, so let's just quickly go back. Yes. So for part B, I just built DFAs all over the alphabet X and Y, and the pattern I use for all three is the same idea. I only need to remember that maybe the last 1 or 2 symbols have been seen, and so because of that, we say that it matters for deciding if I'm about to end in a certain pattern, right? So for ends in XY, my starting point is Q0, meaning I haven't seen anything useful yet. If I read an X, I move to Q1, right? If I read an X, I move to Q1, or if I read an X, I'll still maintain my usual position, so as Q0, right? And so if I read an X, I move to Q1, meaning the last thing I saw was X, so I don't need to transition from a particular place. But since I saw X from Q0, I need to transition from Q0 to Q1 as the transition goes. Yeah. And so from Q1, if I then read the Y, you can clearly see that I need to transition. So from Q, I read a Y and I go to Q2. Yeah, so that's how it works. So in Q2, and then I have maybe just like I've just seen X and Y. So basically I move to Q2, which is my accepting state. The Q2 here is my accepting state. Like Mr. Warner has been saying, the final state. But if I'm in Q1, and I read another X, here, I still just transition. I just maintain my position. I stay in just Q1 because the last symbol is still X. And if I'm in Q0 and I read Y, that's just okay. If I'm in Q0 and I read Y, I'll still maintain my position, right? Because Y alone doesn't help me to move. It just helps me to stay in one position. And notice, even from the accepting state Q2, if I read an X, if I read another X, I move back to Q1. As you can see here, if I read an X, I move back to Q1 because now the last symbol is X again, and the string might continue and still need to end correctly, since we are saying that it has to set of string that ends with X and Y. So here, if I transition from X, if I received an input of X and my initial state is Q0, I'll go to Q1, and if I receive an input of Y, I'll just go to Q2. So the maybe something will come before the XY that ends with XY. So that's how it is. Yeah. And so for this, that is the same thing I did here. That is the same thing. So state Q0, like I said, my start state is Q0. Like the transition state is Q1 and Q2, and the accept state is Q2. As you can see, my start state. This indicates what the start state means. The arrow here will tell you that this is where you start from, and then the double circle here will tell you where the machine has been at, where the machine has the computer has accepted the language, where maybe machine has, yes, short. And so with this one, they are saying that the last two symbols are supposed to be XX. And so if the machine reads an input of X, it transitions from Q0 to Q1. And also if it reads an input of X at Q1, it transitions from Q1 to Q2, as you can see here. And then if I'm at Q2 and receive an input of X, basically I still maintain my position. And if I'm Q2 and receive an input of Y, go back. Here we are saying that the language should be XX, right? And so back again to QY, I mean Q2 receiving an input of Y, back to Q2, Q1, Q0, Q0, and at Q0 you receive an input of X again, back to Q1, and Q1 receive an input of X. As you can see, we have the ending state or the ending string, the ending values as XX. That is why we are saying that it should be it should end with XX. Right, that's what we did here as well. Like I said, I'm using the same technique to explain the three different terms that we need to do as part of the question. And so with this, like I said, as been saying, the Q0 or Q0 is our start state. Q1 is maybe the transition state. So all these are transition states, but we have some special ones that, as part of automata course, you cannot ignore them. I mean, all of these things you can't ignore them. The start state, the final state, or the accept state, or the rejected state. All these things are so essential. And so with this, the last symbol, or the last symbols that it accepts is YY. It ends is YY, right? And so if I'm at my start position, the Q0 position, I receive an input of Y, I should transition from Q0 to Q1. And if I'm at Q1 and I receive an input of Y, I still have to transition from Q1 to Q2. And then Q2 is our accepting state, or the final state. So as you can see here, it means that maybe you have some strings before, and the last strings, which are YY, will come to end the accepted values, or the accepted strings that the machine will accept. So with this, like I said, it's just something short that I want to do for you today. And as part of the whole course, we will also just add them to, but this is not mainly on the others, but just for the short, it's just for tax 1. And so that is it for now. I'll just quickly thank you very much.